Somebody tell me a story. What'd you do this weekend?
Can JP, how'd the Pfizer go?
Do you ask something?
How'd the vaccine go?
My arm is really sore right now, but other than that, I'm feeling fine. Yeah.
No,
Oh, go ahead.
no government conspiracy is living inside of you.
No, it was really funny because once I got it, we were like, I just started chanting like microchip, microchip, and all like the farm students are looking at me, and I was like, no, I'm just kidding. It's a farce, maybe. I don't know. But no, yesterday I was just really fatigued, like almost like a almost like a non-sober state, if you will, just of like
So much more than usual. Much more fatigue than is the usual.
than I think is appropriate. Yeah.
Okay.
So, yeah.
So how's everybody else? How's all the non-vaccinated folk?
Honestly, like it's not that I don't believe in vaccinations. I get vaccinated for like the flu and all those things. I just want to wait a bit and see like
how
maybe
JP
wait
does.
a couple more. Yeah, because like I don't, like pretty much stay in anyways. Like I don't expose myself, much. So like I'm just gonna wait like maybe like another month or two to get the vaccine.
Yeah, me too. I mean, that sounds reasonable. Just make sure nobody's having, giant reactions or whatever. JP, keep us updated.
Of course, if I just suddenly die one day from the vaccine, I'll let you guys know.
Your absence from class will be noticed. We'll all panic.
I probably just overslept the class, but either or, slight concern should be raised.
Okay, let me pull up the slides. I don't think we'll actually go over today. We keep going over, but I do not think today will be one of those days. And then afterward, for everyone who's here, we should chat about comps and when you want to take them. If you're not doing thesis, we can talk about thesis. We can talk about some program logistic things and when you want to take the tests and whatever. I mean, you just do it from home. It's not going to be hard. That's the nice part about doing comprehensive exams in the age of quarantine, is you just sort of take your time and write up whatever you want, and we'll talk. Unless people have questions right now. It sounded like there was an unmute.
I mean, I have questions after class about like the thesis process. Okay. That'd be great.
we can talk about whatever after class. I don't think this will go the whole time. It might come close. I don't know, but okay.
Hi, Jensen, real quick.
What was that?
Hi, Jensen.
Hey. So we've been talking about stress and the breadth of stress and what adaptation looks like, the reasons we adapt, how we adapt, the precise nature of adaptation. But sometimes things go wrong. Sometimes we adapt in a disadvantageous direction. And today we'll talk about the reasons for that and sort of what goes awry. And it's not really your body. It feels like it is. It feels as though your body is misbehaving, but it's very seldom the case. Usually your body is doing what it's supposed to be doing, but it's given a confusing set of instructions and it's doing the best it can to respond to those instructions. So we went over all of this last time. We went over the major people last time, and this idea that the body is designed to be conservative, right? Designed by exposure, designed by generation. maybe designed by more than that, but certainly designed by serial exposure, where if you do with that form, that's going to be tough. But if you do the monkey bars every single day, you're going to get good forearm strength, or you're going to get great forearm strength. That's not going to make you a good bench presser. Right. And it's not going to make you a good rope climber. You'd think these two, all this forearm strength, you'd think those two would go kind of, pun literally hand in hand, but they don't, right? These activities, even when you start looking at different yoga poses, Genevieve, I'm assuming you're here. When you look at two, three, four, five different yoga poses, it calls upon balance in a very different way. The neuromuscular recruitment characteristics, which muscle groups are required, the nature of recruitment in those muscle groups. Getting good at one yoga pose does not make you any better at another. And watch somebody learning to play an instrument for the first time. Just because you learn, B on guitar does not make you any better at playing F. Right? It does. When you learn a particular piano chord, that doesn't mean you can play all the other chords, right? So that there are different finger positions, and you really like get really good at all of the, just standard, A through G and flats and whatever, sevenths and stuff, and then add some weird jazz chord. Have somebody from the Brubeck Institute, which isn't at Pacific anymore, but once upon a time it was. Have somebody from that show you some weird jazz chord, and you have to look at your fingers. You're like a pro guitar player, and you still have to look at your fingers and be like, okay, how did I play that one, and learn the new chord. Maybe you can learn it a little bit faster, but just because you're really good at guitar doesn't mean you're also good at that chord you've never played. And so we adapt according to the fingerprint, that very precise fingerprint. And some of this is just the way the nerves work, the way your brain, the central nervous system, and the way all of that works, right? You need exposure before you're not just gonna intuitively be able to perform things. But also, this is a high estimation, but just remember, any protein you have to create, if you're going to reinforce a tissue, if you're going to hypertrophy, if you're going to make a tissue withstand future bouts, whether it's Wolff's law or Davis's law. We got bones, and we got some ligaments and soft tissues, and whatever it is. If you're translating proteins, if you are adapting, that's so expensive, and the body doesn't want to do it. So usually what you do, right, is you accommodate, and then finally you adapt, because it's like, there's just too much accommodation. It's actually more efficient in terms of the eventual metabolic expense if we just adapt to it, so we can just tolerate this without discomfort, without all this hassle of toleration and accommodation. So remember, skeletal muscle, super adaptable, right? You can adapt it in whatever direction. Give your muscle a tan, that's fine. But there's a genetic ceiling, right? Are you a mussel or a clam or a scallop is what this is, an oyster? Are you some sort of bivalve mollusk? Are you a chicken? Are you a duck? Are you a frog? You're going to have a very different genetic starting point and capacity and inclination. People, we're pretty well rounded, right? People are pretty well rounded. We're not. We're really good at aerobic stuff. We're not good at kind of upper high threshold motor unit stuff. Go to the zoo, close your eyes, spin some circles, and point at an animal. It's probably going to beat you in the 100, but you'll beat it in the marathon. Just train for a few months, and you will beat it. I mean, just look at the humans versus horses marathons, and humans are, they're like giving horses pit stops these days. And so but we all have innate capacities, and one human is not another human, right? So if you're Voldemort or Bun guy, you don't have the same starting point. Your origins and insertions can be different. Type 1 versus type 2 composition can be different. Enzymatic concentrations can be different. I mean, there's all these baseline limb lengths, all these baseline differences, but we can always train to improve or get worse if we train badly. And so that's what this lecture is going to be about a little bit, is why are we getting worse? What is the mechanism for deterioration. And we'll talk in more detail later in the semester as we get into things like overtraining. This is just at the level of adaptation and stress response. Big picture stuff. So, isometric, you're going to get better at isometric. It's not going to make you good at movement. Dynamic begets dynamic capacity. So if you do dynamic exercise, you're going to get good at dynamic capacity. But if you're running at a 6-minute mile pace, you're going to get good at running at a 6-minute mile pace. It's not going to make you good at running at a 5-minute mile pace. It's not going to make you good at running, 20 miles at a 10-minute mile pace. It's going to make you good at what you're doing. The muscle is contracting at a very specific velocity. Now, you are going to take on enzymatic and structural characteristics to be better at that contraction velocity. That contraction velocity may be worsening your performance at other velocities. And so we're going to get better at the thing we're doing, often at the expense of peripheral capacities or unexercised capacity. So eccentric to eccentric, concentric to concentric, eccentric to eccentric, right? So these are the things you're going to get best at. Do concentric if you want to get good at concentric. So if you want to get good at concentric things, go use Proteus. It's nothing but concentric. And so you're going to get a lot of neuromuscular adaptation, and we see increases in pitching velocity, stuff like that. And probably we would see the same thing with tennis, because you're replicating a tennis swing loaded, isometric, loaded, concentric, and you can replicate, especially have the tennis handle. You can do it, but you'll probably increase your tennis racket velocity, which would become ball velocity. But I'm not. I don't know that much about tennis, and I think Ross and Liam can offer more input on something like that. But it's not even just in the cells. We're looking at specificity of adaptation in the extracellular space. So that extracellular matrix, we see some adaptation there, and that's probably a good explanation of these couple of articles down here are talking about contact adaptation. I thought Mike Tyson explained it better, but he just wasn't talking about the physiology. But the reason we have contact adaptation is probably a lot of extracellular matrix adaptation. So that's not even in the cell, right? That's outside of the cell. We're seeing specificity of adaptation, and the specificity of specificity. When we talked about circling the globe and no two stretches of road, no two undulations of sand or whatever are the same, get into that cradleist philosophy. My sweater today is not my sweater tomorrow. The snowflakes, we all know snowflakes. Now, Forbes, this isn't a scientific periodical. This isn't like a peer-reviewed journal, but their calculation was nice. Who cares if it's true? It's giving a glimpse, even if it's off by 50%, it doesn't matter. It's the premise of there's like infinity snowflakes out there, and remarkably few and so the Earth eventually cools enough to have weather patterns that can have snow. And if you start measuring every snowflake since the Earth stopped being a ball of lava, maybe we have 5 that have been identical. In a laboratory setting, maybe you can create identical environments. But what makes a snowflake? Well, it's the environment. Okay, we have precipitation, fall tumbling toward the Earth, and the environment it passes through, from cloud to ground, is what creates the snowflake. Why is every single snowflake, or how rather, is every single snowflake unique? Let's just say every single snowflake is unique. How are they unique? Because no two environments are the same. Two snowflakes fall in tandem, right? They're an inch apart. Their environments are different. Yeah, they both fall, snow never falls in Stockton. They both fall in Indiana. They're in like Indianapolis on March 1st at 10 o'clock p.m., an inch apart from the same cloud, and they were both I don't know, absorbed from the same person's pee, whatever it was, and they're totally different, these two snowflakes. Why? Because no two environments are the same. You're an inch apart, and the environment is different, and that environment determines adaptation. Now, how a snowflake adapts and develops, that's different from how we develop, but the principle is the same. Specificity is so specific. And it doesn't just apply to snowflakes and Mike Tyson punches, just anything you're doing. Go jog. What does your gait look like when you jog? I jog on the same stretch of sidewalk as you, let's say. Does my gait look like this and yours look like this? Our adaptations are going to be different. Am I running with the knee braces and I don't know, like a necklace and stuff? That's going to change my cadence, my gait, it's going to change things. It's going to change points of interaction. The shoes, well, that's going to change how your foot engages with the ground. Adaptation is always different. Your shoes, your socks, your clothes. Do you have a tourniquet on? That's going to change things. That'll change blood flow kinematics, right? So you're going to look at how the blood flow changes. That changes adaptation. So every little tiny thing is going to change the portfolio, right? Are you in a weight room? Are you golfing? The profile of stresses is going to change. And so the type of load, the rate of application, all of these variables matter. This is the characteristic of how you jump on the trampoline. You remember the trampoline example where we have, if this is a human cell, right, we have mechanotransducers in here in this little space. We have the springs of the trampoline. This would be like integrins, the extracellular load sensing proteins that relay messages into the interior of the cell. So you load a cell, and you're going to have all these mechanotransduction proteins, cadherin cell to cell, titin within the cell, zetus to M-line, integrins, extracellular matrix to the inside of the cell, out there with all that collagen and those glycoproteins and proteoglycans and that environment immediately outside of the cell. Transmembrane protein, it crosses the membrane. Cadherins, transmembrane protein, it crosses the membrane. Titin is not a transmembrane protein, it's just inside of the cell. But we have these proteins that are sensing the way that you jump on the trampoline and relaying that message indoors. Now, too little stress, bad, right? That's atrophy, that's bad. Too much stress, that's overtraining, that's injury, that's bad. You need your Goldilocks. You need your little Goldilocks space, but you can't just do your one exercise. Well, I go to the gym all the time. I'm very healthy. I'm so fit. I go to the gym 4 days a week and I do the treadmill for 20 minutes. And then I do squats every Monday and I do bench press every Wednesday and I do whatever rows and shoulders every Friday. And on Saturday, I do plyometrics. Okay, well, you're only developing to those things. Those are the only things. When was the last time you climbed a tree? Right? When was the last time you ran through an obstacle course? When was the last time you took a tumbling class? The world is filled with stressors. Your tissues, where yoga is really good at hitting a lot of those muscles that you're not going to hit in the weight room. So what you don't want is your movement profile to be, I sat around all day and then I did 20 minutes on the treadmill, 3 sets of squats, 4 sets of lunges, and 6 sets of bench. That's like maybe the right dose of one particular thing, but it's only one stressor, right? And so that's when we start getting into this advice when some strength coach or sport coach is like, all right, go serve 50 times if you're tennis. Go pitch, 50 curves or fastballs or change-ups or whatever. You're overexpressing one thing. And are you counterbalancing that with the opposing forces, with the opposing muscle groups, the antagonists? If not, you're likely to be injured. You're likely to express disproportionate strength in some particular joint, at least across some particular joint among muscle groups. And disproportionate capacities lead to injuries, and then injuries beget injuries. As soon as you're injured, you're going to start changing your neuromuscular recruitment patterns, and then it's going to be hard to get back to where you were before. Even if you can produce the same amount of strength that you could before, your muscle recruitment characteristics have changed, especially in things like the shoulder. You do see it in the back. Odson DeLuca, one of my favorite studies, was talking about in the back. Lots of follow-up studies on that confirming it. But in the shoulder, you see all sorts of differences in how you're recruiting the tissue, from your bicep recruitment characteristics to the rotator cuff muscles. I mean, it's just everything changes in how it's being recruited. So you want to be cautious in this, like, go do your one thing. And you remember our 6 points, the 6 points we ended with last lecture. Every stress is unique fingerprint. Every single stressor is going to create a different adaptation, just like every single weather square inch is a different weather pattern. It's a different set of environmental factors that elicits a different development of snowflakes. Every single moment of your life is unique and creates a different set of stressors. There's no such thing as general adaptation. You don't adapt generally. Otherwise, every snowflake would be identical. General adaptation syndrome, where we're like, oh, whatever the stress is, we adapt identically to reinforce our tissues against that. Every snowflake would develop in the same way. Every sinew in your body would develop in the same way. Everything adapts, right? It's not just your muscles, it's everything. And it's all aimed at self-preservation, for the point of gene replication, for the point of seeing your gene cast off into a future generation, so your genes can go on surviving and propagating, whatever. But self-preservation, that's how we experience that phenomenon. And every creature is constantly making changes to better tolerate its environment. Even like inanimate things are commonly making changes. And corrective exercise, physical therapy, things like that, if for a recovery clinic, application of appropriate stresses or withdrawal of inappropriate stresses, that's also very effective. So what adaptations, we have Cellier down here, and he's listening carefully to the breathing, the labored breathing of this guy lifting his little pinks. What adaptations are made if you run, or if you lift, or if you play yogas? What adaptations are made? The exact adaptations that enhance your ability to do that exact thing, that exact exercise at that exact speed, at that exact load, with that exact weird neck position. That's what you're adapting to while flexing your abs super hard. Whatever the exercise you're doing, you're adapting to running in that shoe at that rate of muscle contraction, in that particular weather or climate, humidity and wind chill and temperature, that those environmental factors at that particular slope or incline, at that particular slipperiness of the road, at all, or at that particular sleep state. That's what you're adapting to. It's so specific. So what adaptations are made if you play hockey? Hockey adaptations. Now, you're not going to grow your teeth back, but you're going to make hockey adaptations that are, if you're the goalie, right, there's going to be some flexibility stuff. There's going to be reinforcing the tissue so you don't snap anything when you do this. There's going to be reinforcing of, I don't know, pecs and internal rotators and stuff. So if a hockey puck hits your hand, it doesn't just rip your shoulder. There's going to be speed, sort of a velocity adaptation of reaching out really quickly, a reactive sort of reaction time, and sort of type 2, how quickly can you move out? All of the adaptations that would be ideal for hockey for this particular position. What adaptations are made if you play Bikram yoga, right? The hot, that you're like in a sweaty 100 degrees and you're posing. What adaptations are made? I'm sure Genevieve is like rolling her eyes at me right now. But what adaptations are made? Thermal regulation in that particular state of exercise. It's not necessarily thermal regulation during a jog. Now, there's overlap, right? Let's not throw away Edward Adolph with his commentary from the 50s. There's overlap. Adaptates overlap, right? And so your body's ability to sweat, how quickly you sweat, how robustly you sweat, how much sodium is lost in your sweat. Let's taper the sodium a little bit that we're losing in our sweat, and can we anticipate exercise and sweat ahead of time, and how your circulation might be able to dissipate some heat. So all of these adaptations may work in multiple situations, but really what you're doing is adapting to be able to perform yoga better in hot weather, in those particular poses that you're doing, not other poses, not other poses. You're still going to be bad at those. What adaptations are made if you play Bikram hockey, right? I don't know. You learn how to skate in the heat. Maybe it's not ice, right? You learn how to rollerblade in the heat. You learn how to swing your stick to the puck in heat or whatever. That's what you learn how to do. So if you stop all of that, if you stop your hockeys and yogas, you stop doing all of this, you begin to lose your adaptations. You begin to lose the capacities that you have developed over the course of your exposure. Does it go away immediately? No, there's a rate of decay. Just like go lie down in bed for a week. You're going to wake up lighter the next week, unless you spend the week eating, but you're going to wake up with atrophy, with muscle atrophy in a week. But does it hit you? Does it just like, is it like a clap on loss? No, it takes time to decay, and different adaptations have a different decay rate. Remember, environmental adaptations, if it's, altitude or heat or something, might linger a little bit longer than weightlifting adaptations, where it's just sort of imposed stress, pull-ups and stuff like that. That might decay a little faster. Or just aerobic capacity. It's running on the levee. That's going to go away really quickly, is your aerobic capacity of sort of levee running. We'll talk about the mechanisms of that. Now, if you stop moving and you put age onto this, it's really going to ramp up the rate of decay. And this is just hand grip strength. People use hand grip strength, squeeze a thing, as this standardized assessment for everything, for health and for lifespan and health span. And if we all did our hand grip today, it's a pretty good predictor of how long people are going to live. As people inch their way toward the grave, we start seeing hand grip going down, 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 down. And so there's some strong models that show hand. You'll see this all the time. Hand grip as a standardized metric for health and human performance and stuff. But it deteriorates with age, and if you stop moving, it's going to deteriorate anyway. So how should you move, and how should you exercise and engage with the world's stresses if you want to build capacities and retain capacities? Exercise for maintenance. Well, do a task analysis. Figure out what it is that you need to do, right? So if it's tennis, pull out a piece of notebook paper and write down every single task that happens on the court. Okay, videotape yourself playing for a whole day. How many steps do you run in one direction? How many times do you change direction? How many times do you run forward? How many times do you backpedal? How fast are you backpedaling? How much do you jump? How high do you jump? The frequency of jumps? How many steps before jumps do you get? Are you just do you have to jump in a quarter of a second? Do you have like a full second? Figure out exactly what you need to do, and now you can tinker with the exercise prescription to be able to maximize capacity in those things. But start with the task analysis. When I watch a soccer team, let's say, go do exercise, they're doing the exercise prescription, and I'm watching a goalie run laps, I know this coach has no idea how a human body works. The goalie is running laps. It worsens the goalie's capacity to do vertical jumps. It worsens the goalie's reaction time and speed and explosiveness and stopping the ball. The goalie gets worse if you have the goal. Now, I get that, like, we do things as a team, right? We run laps as a team. We win as a team. We lose as a team. We do everything as a team. Okay, there are better ways to develop and demonstrate camaraderie than losing because of a bad training program. Train as an athlete, win as a team, right? Have camaraderie in the victory. Don't have camaraderie in the loss because you trained like idiots, right? Don't do that. So there are less destructive means of training than having the goalie run 2 miles. I mean, if the goalie's VO2 max is like 70, the coach has no idea what they're doing, the strength coach or whatever. Or I know nothing about soccer. Maybe a goalie needs to run 6 miles during the course of a game. I don't think so. though. Correct, Kendall, at some point correct me if the goalie really like runs up and down the field all game long. But so we have to figure out what the appropriate stressors are and apply them. Now, what happens? Why are there so many physical therapy patients? Why are physical therapists paid so much? Why is there a need for more physical therapists, and we can say occupational therapists at the same time for all of those sentences. Occupational therapy works too. Why are we understaffed, and why is it so easy to get a job once you have a degree? Everyone's hiring and there's great job security. Why? Well, because there's so many patients. Just everybody is injured all the time. Everybody is just broken down and in need of healing. And why? Why is the whole world dealing with ailments of musculoskeletal nature, right? Oh, my muscles are this, my tendons are that, my bones are this. And why? Well, load profiles, snowflakes. The snowflake falls from the cloud, and by the time it arrives at the ground, it has hit some weird winds and weird weather patterns and weird temperatures and weird other, collided with some other raindrop, and it has encountered things. Some of those things were inappropriate, so it developed in a weird way, and now you have pathology. Weird moving, weird load profiles. That's what's unhealthy, right? That's how you develop musculoskeletal pathology. Now, are there genetic predispositions? Are there genetic factors that are going to play in? Yeah, obviously. I mean, like we don't even have the same number of muscles in our body. Maybe some of us have different numbers of bones than the next. There are genetic differences from person to person. And so this is not 100% of every patient who's ever been admitted to a PT clinic or, to a OT therapy. But this is the great bulk of humanity and our ailments, whether they come from sports, whether they come from activities of daily living. It's weird movement. And if you look at SeaWorld, this is one of my favorites. Some of you have heard me go this sort of example before. It's just one of the best examples there is of inappropriate mechanical loads. This is the Southwest plane had a SeaWorld one. Now, this was photoshopped, right? They didn't, this wasn't the plane because I don't think that would fly very well. That's not a good adaptation for aerial, of movement, whatever. But neither is this good. Right. So when you go to SeaWorld, especially the males, like 100% of males, but all of these orcas, every single one of them, if they're there long enough, not the day they arrive, right? It takes time to adapt, just like it takes time to decay. You come off the mountain with your great VO2 max and your altitude, adaptation, and you're not like a normal person on day one, right? It takes time for that to decay, and it's certainly going to take time for this to develop. But if they're there long enough, if those orcas live there at SeaWorld or in one of these, tanks, it doesn't have to be SeaWorld specifically, but in captivity, if an orca is in captivity long enough, this happens. This little tail happens. They call it flaccid fin syndrome. Not a good name because it's rigid, right? Not a good name. It's very rigid. And so the flaccid fin syndrome or folded fin syndrome, if we're going to keep the FFS, sometimes it's folded fin syndrome. But there's a really nice master's thesis at Nova Southeastern University in the 90s. This book talks about it a lot more. What are we drawing? Did I do that? This little like yellow drawing over here. So the flaccid fin or the folded fin syndrome. What we're looking at is, can you guys see this little yellow drawing? Is that just on my screen? Let me pull up the chat box and have that open. Okay, now Kendall is chiming in and saying, okay, so we have little like yellow drawing here. Okay, so yeah, the goalkeeper does not run 6 miles in the game. But I have no idea how to undo this drawing. But so the flaccid or folded fin syndrome, what it is a, sorry, I'm using my phone for the first time. It wouldn't let me zoom in. Okay, whatever. iPhone to everybody. It's character, like it's like mustard on the screen. It's character. But in nature, in the wild, in the ocean, outside of captivity, when Free Willy like leaps over the little boy and goes out into the great wide open, out in that open, you do see fins, dorsal fins that are a little bit weird, right? They're a little bit abnormal. They're a little bit distorted somehow, but that's not like folded down over the body, hugging it, whoa, just gotta hug you a little bit closer. And it's not a cuddle party, right? So what you see is names like hook and corkscrew. I think there's corkscrew right here, where there's weird patterns, and you know how these things would develop. It's patterns of exposure in the water. I assume this orca is swimming in weird ways, is darting in and out, is doing slaloms through the sea or something to make this thing develop in this way. Now, in New Zealand, there are collapsed fins to some degree. Often it's a little hook. When they say the name like hook, what it does, it comes up and has a little tiny hook at the top, like it's a back scratcher or something. Not like it's folded down. But so some amount of abnormality. New Zealand has sort of a high percentage, almost a quarter of the orcas out in New Zealand have some amount of deformity. They don't look like SeaWorld. They're not crazy, but a little bit of deformity. British Columbia, it's a little bit lower. Norway, right? The Vikings, those things are just firm and straight and erect. Like that's a Viking orca out in Norway. There's like very few of them have any sort of one out of 174 or whatever. So the reasons for this, you already know what it is, because this is stress physiology and we're talking about load profiles and environments. So this is really the big one. The reason when you go to SeaWorld and you see these silly, weird little, bendy dorsal fins is repeated exposure to a mechanical stress. Counterclockwise, swim in a circle. Well, where's the water pushing? On the fin at an angle, which makes it fold, right? So what do braces do? When you put braces on your teeth, what do? They put constant load, constant tension on your teeth, and eventually your teeth move to wherever the braces are pulling them to. That's it, right? So it's the same thing. If you put a killer whale, if some orca, right? You put these things in SeaWorld and put the aquatic equivalent of braces on their dorsal fin, of course it's going to fold in the direction that the water is pushing. Now, on top of that, surface swimming, right? There are not these high static fluid pressures, right? When you swim at depth in the ocean, sort of simulated microgravity and these fluid pressures, that is very different than if you're just swimming at the surface and your fin is just having the surface water shoving it and gravity tugging on it. And so the idea of constantly at the surface, constantly having the braces shove it in one direction. And then the dietary explanations, they're not out there eating whole live fish, right? What they're eating is dead frozen fish and some gelatin. And maybe the nutritional profile is not optimal for tissue integrity. And so it's set up in this nutritional environment to be a little kind of flimsy already, maybe, sure. But the major reason is specificity of adaptation. It's specificity of mechanotransduction, specificity of adaptation to load profiles, how mechanical stresses are applied to a fin determines, I mean, this is as determinism as it gets, right? It determines the reaction, the response of that fin. It determines adaptation at the level of gene expression, at the level of protein synthesis, at the level of permanent architecture. So that's the load profile. So the consequence of inappropriate mechanical signaling is this little guy right here. This fin just comes down and hugs the side because the water is constantly pushing on it. The water is constantly pushing on the fin, pushing on the fin, pushing on the fin. And of course, it's going to fold down and hug the body, especially when the gravity is always pulling on too. So nobody in the room, yeah, maybe we have the genes to grow a tail, but nobody has a tail. Nobody has a dorsal fin. We don't have all these aquatic features. Now we have a recurrent laryngeal nerve, which would have been awesome if we had gills, but we don't have gills. But what we do have, we do not have this, but what we have, everyone has a back, right? I have a back with 3 herniated discs in it. Ross has a knee that's a mess. Somebody else has a shoulder that's a mess, a neck that's a mess, hips that are a mess, feet that are a mess. We all have some sort of joint or body segment, some little hunk of flesh, meat and bone that is messy, right? That is injured, that is not optimal. It's a dorsal fin. It's a dorsal fin, and the reason it's not optimal is it has had a load profile that wasn't ideal. Now, there can be micro trauma, right? Or there can be macro trauma. Macro trauma, like with Ross, I think I can't see anybody's faces, so I have no idea if you're like nodding yes or no or going at me or whatever. But I think you had macro trauma originally. I think there was a big injury at the onset, and that's going to change how your knee receives future load profiles, what tissues are absorbing that load. And so the macro trauma is like, I was in a car wreck. Okay, definitely. So I was in a car wreck and the steering wheel just shattered my arm or whatever. Okay, that's macro trauma, right? That's not something that's inappropriate. That's not SeaWorld. That's not over the course of 5 years, the water is gently, pushing on your knee, your back, your arm, your dorsal fin, whatever. Macro trauma is a little bit different. The consequence of macro trauma is also an injury, but micro trauma, that's SeaWorld, right? Micro trauma is what you see in most Achilles injuries. If an Achilles snaps, that's micro trauma built up year after year with inappropriate loading, and the dorsal fin is already totally folded by the time that Achilles snaps. And so we do all this stuff, we put braces on things, and that's going to change the load profile. As soon as you put sleeves and braces on things, that changes how you run. Earlier, I had that picture of whoever it was, the like WWE wrestler running. And he was wearing all sorts of braces on his knees and elbows and tourniquets on his arms. And that changes how the body receives loads. It changes where that load is absorbed. It changes which tissues are adapting, specificity of adaptation, specificity of mechanotransduction. If you change a load profile by putting on a sleeve, by putting on a different pair of shoes, by carrying weights, by changing your gait, you're going to change the adaptation in those tissues. And so we have dorsal fins all over our bodies, right? We have every single joint is just filled with dorsal fins that can respond to aquatic braces. And our environments, they're not natural, right? We when you're born, you come out of the birth canal, it's like weird and bright and wet and confusing, and then suddenly you've fallen from the clouds and you're on your way to the ground, and every minute of your life is different. It's presenting different loads. It's presenting different stresses. And so you're going to snowflake your way to the ground, and we all develop differently. Sit too much, load profiles change. If you sit too much, your load profiles change. I'll show you what that looks like in just a minute. And we're going to actually have a lecture on sitting eventually when we're talking about physical inactivity as a stressor. Bench press too much. You see guys who do that, go to the gym, and the people who just all they do is bench press. It's usually like high schoolers, but all they do is bench press. And you see this forward, this anterior kind of rotation of the shoulders. They get this sort of kyphosis, this bench press induced sort of kyphosis where they just kind of roll forward, and eventually what they're going to end up with like numb fingers, because the brachial plexus and the subclavian artery. As Ross says, tennis rolls the shoulders really badly too. So that's a good point. A lot of this, not just bench press too much. What is your sport? Is it always forward, 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 forward? There is a backhand in tennis, but I don't know how many forehands you're going to do before you have a backhand. And if you're doing like a 2-arm backhand, you don't really go back as much as you go forward. As I'm just visualizing, not a tennis expert, right? Ross and Liam are resident tennis experts, but when you swing forward, you really do a swing that goes forward. I mean, that's like a cable crossover. When you go back, you don't really move the arm. Like it's not like a full on like reverse pec deck row, I don't think. And if we're going to look at the number of forehands versus backhands, it would make sense that tennis rolls the shoulders forward. And as you do that, if you don't counterbalance, right, by working the opposite, do some rows and reverse pec decks and whatever's now and again, you're going to compress the clavicle, right? Your collarbone, and your first rib, your highest rib is right. The first rib is really high. It's not like halfway down your chest. It's like really high, and it's right there with your clavicle. And when you roll your shoulders forward, those two compress. What runs between that little narrow space between your clavicle and your first rib? The brachial plexus, which is all the nerves for everything in your hand, your arm and hand, and the subclavicle artery. And so that's all the blood flow for down there. And so there are consequences to a lot of these stressors that change our dorsal fins, that change our shoulder posture, that change our back posture. There are consequences to these loads. It's not just like, well, it looks weird. There are performance detriments. There are pain explanations. Wear high heels. What's going to happen? Well, what are you shortening? Right? You're in constant plantar flexion, and when you do that, you're shortening the gastroc and soleus. The gastroc crosses two joints, right? And so it's a knee flexor as well. And so you start to see postural changes at both the ankle and the knee when you wear high heels. And then what happens when your knees become more flexed? It affects your back, right? And so a lot of these things, the one dorsal fin affects another. Carry all your stuff with one arm. Go work at a restaurant. Go work at a restaurant as a server, a busser, or whatever, and carry trays. People aren't like ambi carriers. Maybe you are, and that's wonderful if you are, but people tend to carry a tray on one side. You're walking to your table carrying the tray on your dominant side, your dominant hand. What happens? Well, the non-dominant side of your back becomes the dominant side of your back to such a degree that you can just look at any experienced server's back and tell what hand is dominant, because one side of their back, there's this bilateral discrepancy that's hilarious to look at. One side of the back looks like, the Incredible Hulk, and the other side looks like Barbie on a diet. It's just this, I mean, you would expect that because the load profile is doing that. You're carrying trays, especially if it's somewhere fancy with heavy plates, or somewhere cheap with really a ton of food. Where the portion sizes are like 5 pounds. Load profiles, wear a sports bra is going to change things, right? Wear a jock strap is going to change things in the same-ish way. And so all of these environments aren't natural. So this is neat. When you look at biomechanics is all biology. It's living things. It's bio 51, it's bio 61, right? It's organisms, it's trees, it's you go into botany and you're talking about biomechanics too. The wind developed this tree. That was an environment. The snowflake that falls from these clouds to that, ocean, whatever, on the way there, it develops. As this little seed becomes sapling becomes bent tree, the wind is blowing this way the entire time. That's why it develops that way. It's not like it's, well, the wind is blowing this way and I'm trying to make myself aerodynamic or whatever. No, it's going to bend with the wind, and that's the dorsal fin, right? So if this were an orca, the water is hitting the fin from this direction. That's the exact same thing as an orca fin. The orca fin is this tree where the wind hits from this way, the water pushes on it this way, it develops in that direction. It's the same thing. It's the same thing with you. Now, let's talk about sitting. This is from that book, Move Your DNA, which is surrounded by yellow markings. So you spend a bunch of your day. This is the actual from the book, from chapter 4 of this wonderful book. Let's say you spend a hunk of your day in this position, right? You're seated in like a little kid's chair, and you don't have any arms. But what we're looking at is the angle, this pelvic angle, right? So this sort of obtuse angle right here, and we're shaped by this stuff, right? Body tissues are going to adapt to joint configurations. This is a joint configuration. The tissues are going to adapt to that. Now we sit a lot. I'm sitting now. Many of you are sitting now. Everyone has sat at some point today, if you're not already sitting. This is these fixed skeletal postures. This is not acute. This is not like, well, I sat down for 5 seconds and then I got up. These are long suffered stressors. This is a dorsal fin when you sit down. This is water blowing on it. So, maybe you sit in this way. It depends on what the chair is, right? Is this like a fourth grader's chair? Is this a car seat or a plane seat or whatever? I mean, these things that seem designed to destroy spines. But when you get up, right? This is copied and pasted. I mean, this is a screenshot from the book. When you get up, you probably think you're returning to this position with this normal upright posture, but it's probably actually like this on the inside, because these are long stressors, right? These skeletal muscular postures are endured for a long period of time, and it doesn't just go away, right? If you've fallen asleep with your arm extended, you're lying down and you kind of roll over, and you know what I'm talking about. I think everyone's probably experienced this at some point in their life, and your arm is like totally extended, it's hanging off the bed, sort of palm up, and you lie down, it's comfortable for a few minutes, and then you doze off and you wake up and your elbow is just killing you. I mean, you're in like agony. It's like you're giving birth out of your elbow. What the hell? There's like something gestation in there. It's like, and like you bend it, and, and then it returns. The pain goes away. It takes 30 seconds or something like that, and the pain goes away. Now you have crimp in like your ligaments, and you have this wavy, and it takes a long time for it to return to normal. So the pain goes away. Oh man, that hurt. That was weird. It must have been like a blood flow thing. You get back into that position, and like 30 seconds later it kills, right? Because the crimp hasn't returned yet. It hasn't returned to its resting length yet. It takes a long time. Sometimes it can take as long as it took to achieve it. As long as you sat there, that might be how long it takes to undo the mess, and you just recreate the mess so often that the mess never goes away. You're sort of adding dishes to the sink faster than you're subtracting them. And so we return to these kind of poor postures. Now, if you get a cast, right, if you put a cast on, that's really going to change the load profile of the arm. Now, he can't even like bend his arm. Like he can't even bend that. And so that's the load profile. His arm is going to be in for a really long time. We're not getting things like integrin and cadherin and titin signaling really. Maybe he's flexing his arm a little bit inside of the cast or something. But even look at his hand. I mean, this like four-tongued snake earthworm thing. His hand is all mashed up in a weird way. That's a load profile on his hand. His hand's going to be super weird. He's going to, like, let's say he was a tennis player, he's going to have a hard time gripping the racket because his fingers are all mashed up. Or, I want you to write your name. I don't know, it's like hard to grip the pen now because my hand has adopted this new weird dorsal fin posture for being in it for however long, 6 weeks or whatever. Let me sign your cast. I'm signing away your capacities. And when he takes this cast off, he has this little tiny, flimsy, super dark, hairy limb that can only extend like halfway. He sort of loses the capacities, right? This is a dorsal fin. There's a lack of appropriate mechanical loading that's being placed on that arm. Now, this is a fake product, right? Because like, look at these like bulky legs and this kid on the side. I think you can actually order this thing, but toddler tamers, it's like it's like ankle weights, but there's ankle weights for adults. You can go for a jog wearing ankle weights. You put on your ankle weights, go for a jog. Are you burning more calories on that jog? Sure. Are you changing the load profile in what is very likely inappropriate way? Yep. You're doing that too, right? The foot strike is changing. The recruitment characteristics are changing. The nature of kind of neural recruitment is being altered. Um, Everything about your gait gets messy when you wear these, just like if you're wearing high heels, right? If you're wearing weights around your ankles, that's changing things. Now, little kids wear like the big thick diapers, put kids in big thick diapers, and then watch the way they walk. They walk around their diaper, right? Their gait, like if you watch The World's Strongest Man or some like elite powerlifting competition, when people have legs that sort of look like this, but they also have a gut at the same time, and they walk around their legs. I mean, it's just their gait. Their legs are so huge. The Ronnie Coleman legs, you have to walk around them. That's a load profile. That's a totally different load profile. And if you force kids to do that by putting them in these big bulky diapers, just have the feces run down their thigh, right? They'll probably be a better athlete later in life. But it's changing load profiles. It's changing the way students, the way developing, kids are going to walk. And so if you put someone in a cast, you're changing the way they perform whatever it is. Put them in an ankle brace, you're changing the way they load. Put somebody in rigid ski boots, you're changing the way they absorb loads. It goes up to the knees and everyone just hurts their knees. But bodily problems, right? This is not physiology gone wild. Almost everything is not, why did this happen to me? Well, your load profile, it's like orca fins. It's obvious why this happened, Now, again, what I'm not talking about is genetic problems. What I'm not talking about is macro trauma. Why did this happen? Because there was like a huge explosive injury, right? That's usually not the same thing. But when like a problem just sort of develops, like, I just this pain in my shoulder, I've never felt this before, just sort of came, all of a sudden, like I've been playing my sport for 5 years, and then this year, just my shoulder. Yeah, well, load profiles are weird. That's why. And hopefully the physical therapist can undo those load profiles, take it away, and reintroduce healthier loads. So, people get mad at their computers, but the computer does not have a mind of its own, right? AI does not exist. There's like artificial intelligence and like chess. It's like, okay, computer learning is not the same thing as like artificial intelligence. It's still just doing what it's programmed to do. And so the state of programming, there's no free will on the computer's behalf, right? It's just doing what's being told, what the programmer told it to do, what the software is telling it to do, what the line of code is telling it to do. And maybe there's coding that you don't want there, some like malware or whatever, but it's doing exactly what it's being told to do. And so are your cells. Your cells are doing exactly what they're told to do. Again, with exceptions of it. Here we have rogue. The yellow matches rogue. It was destiny to have the yellow there. So biological systems very seldom go rogue. Now, is it possible that you have like autoimmune, like that's very rogue? That's like, we're attacking ourselves. Yeah, obviously there are exceptions here, but for the most part, load profiles, that's sort of the bulk of all musculoskeletal pathology is load profiles. It's how stress is applied to your cells and tissues and body systems. So quoting Calvin Wells, a pattern of disease or injury. This is super old, right? This is not new. The pattern of disease or injury that affects any group of people is never a matter of chance. It is invariably the expression of stresses and strains to which they were exposed, a response to everything in their environment and behavior. Now, stresses and strains, that's sort of an old way of saying it. Stresses and loads is contemporary vernacular, but same thing. This is load profiles. This is diseases and injuries and whoever's being affected. This isn't just like, whoa, the dice were rolled, and I just snake eyes, I'm out. That's not how it works. And so the consequence of appropriate mechanical signaling, people who have nice kind of biomechanical exposures. I mean, you look at these people who have 20 plus seasons in whether it's football or basketball or baseball. And these are people who had healthy, now maybe there's a genetic integrity to the joints, but healthy exercise prescriptions. The consequence of inappropriate mechanical signaling, Kobe Bryant did rupture his Achilles, but he was 34 at the time. And a ruptured Achilles is a pretty classic sign of inappropriate load profiles. But for the bulk of his career, he seems to have a really sound, injury-free, to my understanding, injury-free experience, and then a ruptured Achilles. I don't know who this is, but Brandon Jennings. I just looked up people with ruptured Achilles in the NBA, and at 25, he ruptured his Achilles. That is bad loading profiles. Again, this thing. I mean, you can leap from a building, jump off your roof, and you're going to sprain everything, and you're going to like mess up your knee and your ankle, and your Achilles is going to be fine. Not if you have, it's usually people just like stepping off a curb or whatever, but you look at the pre and the post. So it's 412 games pre, 143 games post, and the performances. Now he was older here than he was here, but 25, that's pretty young for a ruptured Achilles. This is a classic example of inappropriate load profiles. But mechanotransduction, specificity of mechanotransduction, think integrins, especially integrins, but also think cadherins, think titin. That is the explanation of our responses to daily stresses, to daily loads. Now, we need stress, right? Just remember broccoli. Remember the nuclear shipyard worker study of people experiencing radiation, like Bruce Banner, the gamma rays or whatever, the Incredible Hulk stuff. You're not going to get Incredible Hulk if you have too much. You're just going to die. But if you have an amount of radiation, an amount of stress, an amount of emotional and physical and chemical, and if you have an amount of stresses, this bolsters your health. And it just depends, species by species, right? This is a person chicken hybrid right here. She did not give me consent to post that picture, but in the 80s, this is from 1985, we're looking at the risks of exercise, a public health view of injuries and hazards. You don't need to know this article. You don't need to know what it says. You don't need to know its findings. All you need to know is, the public health attitude toward exercise, what it hasn't, little attention, what it hasn't been paying attention to, this is in the 80s, is the focus on the risks of exercise. What are the risks of exercise? And they talk about some different risks in swimming and running and walking, cycling, calisthenics, and racket sports. What are the risks here? Those risks are the same thing as the benefits. The risks are the benefits as long as you don't actually injure yourself. If you're sub-injury, that's the healthy part. Just like an immune system. Don't expose yourself until you're sick. Expose yourself until you've experienced it. And another portion of the sort of Dread Pirate Roberts principle, right? You get used to iocane powder. You develop an immunity to it. You develop an immunity to whatever the load is. You develop an immunity to bench press. You develop an immunity to heart attacks while running. You develop immunities to these things by exposure. Okay, early today. Happy to talk about physiology, happy to talk about comps, happy to talk about thesis. Happy to sit in silence and meditate.
Is there any dates for comps?
What do you guys want to do? I can send out my questions today. I'm sending out my questions today, and you can just start working on them. There's a paper towel. You're right on this. Okay, so Ross and who else am I sending comp questions to? I have a list in my email, but so I don't have to dig it up. Who am I sending? Gigi. Okay, let me get the actual whole view of everybody because I can only see a couple of you. Kendall, did you raise your hand? I think. Okay. And
Can I come in for a little bit?
yeah.
Are these questions for this class?
I'll do it for this class, and I had I had like a brief version of 248. I'll do it for. That was like the quarantine semester where we got halfway through and then it was quarantine. I'm like, I don't know how to do this. So, but I'll come up with something simple for 248. And if you had me for 279, Caitlin, you did. Who else had me for 279? Okay, Kendall, Lexi. Yeah, so me for 279, I'd give you that one too. If you had Peter Wong for 279, then he would give you the question. So whoever you took the class with, you'll probably have one from Peter, one or two from Van Ness, one or two from me, and it's going to be write an essay at home. Normally what comps is no sources, show up, use a computer that doesn't have any resources on it, use one of our computers, and it's timed and there's no notes and you do this sort of intense thing. It's quarantine. Nobody wants this to be any harder than it has to be. So it's not proctored. Just write an essay, open notes, make it pretty good, right? Write pretty good, have a couple citations, make it good. But it just doesn't need to be a punishing experience for people. Like quarantine it's like life is hard enough right now. This doesn't need to be an additional difficulty. Sorry, let me look at the chat box. It's premature to receive those questions too. Sure, Hunter. Yeah. And Oscar.
So would we have to reach out to Peter? If we
I'll
had
do
to...
it. Yeah, I'll do it on your behalf.
All right. Okay. Thank you.
Genevieve, yeah. And I'll go through my email. I know there's a few of you sent me the comprehensive lists of what you have and don't have, and I have that saved. And so I'll go through that as well. Who is iPhone? I have no idea who iPhone is. Me as well. Oh, Gurdeep. Okay, your iPhone. Okay, Gurdeep. So yeah, I will get in touch with all of you before I go to bed tonight, and I'll send my questions, and then I'll get in touch with. I will CC both Mark and Peter, so they're in the loop. And the due date is just quite a while from now. Don't put it off, because that you don't want to like, oh, I have all these comp questions to write at the end of this semester, and I have finals, and I have a family thing going on. So just work on that process where it's like every day spend half an hour on comps. That's not painful, right? Just after breakfast, spend half an hour on comps, and you'll be done by the time, with all of your comps by the time February is over. Can I also, Celeste? Yes.
I have a question. So I thought I was going to go thesis, and then I'm going now into comps, I think. So I'm confused because I've heard that you take all your comps at the end of all of your classes, or are you taking them as you finish each course?
Okay, so we do them at the end. I'll send the questions to everybody so you know what the questions are, and the questions don't change, so you'll be ready for them by the time they come. If you want to, if you're going to do comps, like just have your questions now. You can prepare your answer now, and then just I don't imagine we're still going to be in quarantine, a year from now, but you can just sort of write up your answer in advance and just be ready. And all right, what was I going to write? And you sort of study what you've already written. It's totally fine. So now what it used to be, one question for each course. That's it. Kendall, your question in the chat box. What it used to be was at the end of each semester, I think, people would just do the questions, but like you're just doing a final right after the final. Like you do the final and then another final like the next day. It was just weird. Like no other school does that. It was this weird thing that Pacific did. I mean, literally like the only school in the universe that did that, and it was just dumb. So we went back to what Pacific used to be. When I was a student, it was, at the end of 2 years, you do your comprehensive exams. That's what every other school does. And so at the end of 2 years, you do your comprehensive exams. And it's friendly in the sense, it's not friendly in the sense that like it's an intimidating test, but it's friendly in the sense that like, what days do you want to do this and what times, and do you feel prepared? And let's just make sure you take it as soon as you're prepared. It's not like on this day you must. So you sort of do it whenever. Now it's the friendliest possible time to do comps because there's nobody's proctoring you. You have the equivalent of unlimited time to a degree. Like, you know, is eventually, will the sun expand so much that it destroys the earth? Yeah, you should probably do your comps before then. But like, it's just whenever you feel like turning them in. So there's no real, oh, I'm just reading Kendall's question the second time. I was about to answer Kendall's question immediately again. But yeah, it's just going to be, I'll send out 2 questions for each class and you just pick one. So for me, for the classes with me, I'll send you 2 questions and say, I like this one better, or I like that one better. Just answer that one. And you do not answer both. It's a waste of time. It's a waste of your time. It's not going to waste my time because I'll just read one of them, but it's definitely a waste of your time for writing something I'm not going to read. I'm just going to read whatever one that like you decide to write. I'll read and I mean, I don't think anybody's at risk of not passing because you can do it from home. Read a couple articles about the subject and just have a really nice answer. So COVID is the friendliest time ever to do comprehensive exams. What I'm not doing is saying thesis track people, everyone switch to comps now, hurry. Like, I'm not doing that because the thesis is a project that you can publish and you can hang that on the publication piece you can hang on your resume, and that is an impressive component of a CV resume. But if you feel like doing comps, yeah, let's do comps. And I'll send everybody I'll just like the whole class. I'll send everybody the questions. And so you're informed. If you're on thesis, you're on the fence about it, then you're informed. What do comps look like? What are the questions? How hard is this? And at least you have more information. That was all the thoughts that I had and all the words I could produce on those thoughts. Other questions?
I have like a thesis related question.
Mm-hmm.
So like when you have your committees, I think Vanessa just answered it, but like you need to have someone not in your department. Why is that? Like to avoid bias or like?
You don't have to. It's nice. You have an outside committee member. So you have 2 inside. You have a thesis advisor, which is probably going to be me, and then you have it can be Van Ness. That's fine too. And then so it's Van Ness and me are going to be on like every single thesis, unless for some reason one of us has offended you so deeply that you hate us. Otherwise, Van Ness and I that's your committee, and then we find one other person. It's fine to do in the department. We can put Peg, we can put Sharon, we can put Peter. People look favorably on theses where there's an outside member for some external perspective. Now, Haley Betancourt, she was soccer. She had the men's soccer coach, was her outside committee member, Ryan Jordan. If we took an undergrad class during our time, you don't take it for that. Yeah. So if you took an undergraduate class, you can take up to 3 undergraduate classes. If you take an undergraduate class, you don't need to do a comprehensive exam for that. It's like a freebie. So everyone take as many undergraduate classes as you can because you don't have to take comps for them. But yeah, so it's or independent studies. You don't have to do comps for independent studies. It's just the HESP specific graduate classes. So if, let's say hypothetically, you do HESP 291, that's an independent study. HESP 297, that's independent research. You do 3 undergraduate classes. There's 5 classes that you don't have a comp for. Now maybe there would be some sort, because like what would I do if I asked you a question on an independent study? I'd ask you about the independent study that you've just like written a paper on or something. Like that's your answer. Like it's sort of silly. And so maybe if I give you the question, you just hand in exactly what you wrote for your, so as a formality, if the graduate school is like, you need to have for independent studies, you just hand me what you did for your independent study, done. But so you can have 5 courses that don't, and you only need 8 courses. You can have 5 of them that don't have comp questions. It just depends how you navigate it. Go ahead.
Any undergrad doesn't have comp questions?
No, because that undergraduate professor would have to grade them, and it just, if you take a HESP undergraduate thing, maybe, right? There may be a comp question if you do a HESP specific undergrad, but if you do bio, if you do chem, if you do anything else, because you can take those courses too. You can go take micro or genetics or whatever. You can take those and totally count them for the masters. And there's no comprehensive exam for those things, because we'd have to like get in touch with the bio professor and say, hey, will you just like, what are you talking about? But so if you do take a HESP specific, it's like if you never took kinesiology before or sport law or something like that, and you do the undergraduate version of it or something. At that point, there might be a comp, but depends. It depends on the course. Like if you do one of Brandon Masai's pedagogy classes, I don't think there's going to be a comp associated with that. One of the if he teaches the graduate classes, there would be a comp. But for one of the undergraduate classes, I don't think there would be a comp associated with that one. But if it's something like you take, I don't know, 147 or something, all right, I'll give you a comp. It's not going to be that bad. What else? Nothing else?
So if we want to do our like planning to do the thesis track, should we just email you and then we'll just kind of put it together and, I don't know, get started at square one, whatever that is?
Yeah, you're not at square one, but yeah, because you have ACSM work that you draw from, and so you have a ton of work that you already have done. You're much farther along than it feels like. Thesis always feels super intimidating. Like, there's so much work, and yeah, but a lot of the work is done. It's 50% of a thesis is data collection, and like, don't collect any, right? Just you're using existing data. All right, you're half done. You're already half done. If you already have analyses, all right, now you're 70% done. And then the writing is going to take a while. But if that's all that's left, it's not that bad. It's just a matter of protecting that process of putting in the half hour a day. Find some specific part of every single day. It's first thing in the morning, and just say there's 30 minutes or 45 minutes, something like that. At some specific time every single day, and be religious about it. Have it be like your ceremonial, this is my thesis day, or this is my comp hour, whatever it is. And it won't take long at all, and you'll be totally done, and it'll be the easiest thing in the world. It's if you don't set up a structure like that, that's the only time it's hard.
And so we're going to need to write a research proposal first, and then get it approved by the committee, and then once it's approved, we can start it.
Yeah, formalities.
Okay.
There's a couple of formalities, but like your research committee is just like Mark and me going, yep, that's good.
Okay.
So sort of logistic bureaucratic stuff is minor hurdles.
Okay. I feel scarred from Peter's class now. So now I'm like,
be on top of dates, and bureaucracy and stuff. But honestly, what's going to happen is I'm going to look at it. I'm going to nod. I'm going to read it, out of respect for you. And all right, good. That's what I'm going to say. Now, if it's terrible, I'll say, oh, can you fix these couple of things?
Yeah.
But like for the most part, like, because they're on occasion, here's where the hassle is. The only part that there's a little bit of a hassle is the part where Mark and I have no control over, which is the graduate school itself. And so if I ask you to fix some specific things, it's probably because the graduate school requires that. And when you submit your thesis to the actual graduate school, which is not the graduate program, right? Health, exercise, and sports science graduate program. And then there's the graduate school, which encompasses all the graduate programs. When you submit your thesis to the graduate school, they're like, oh, it doesn't meet this, you need to format it according to this, and your margins need to be, and so there's going to be some obnoxious, you can just like pay someone $50 to fix it for you. That's what, like, a lot of people are so sick of the thesis by the time they get to that stage, and they just like pay their sibling. Here's $50. Well, I got this list of margin requirements and fonts and spacings, and here's $50. Will you go through the thesis for me and do this? Honestly, half the people do that. So that's that in the bureaucratic speed bumps and sort of obnoxious part of it. That's really the only thing.
So I wanted to ask you, like, with like your experience and opinion. So like they said, at least for us this year, if you're going to graduate in May, it has to be due by March 26th. So, and you have to fill out like a completion form. So do most people usually present like days prior and then fill out the form to send to the graduate school? Or how does that look?
Honestly, most people defend late and then just graduate in the summer. Don't do that though. Just wrap up stuff on time. I graduated. I left. I was like, I'm getting out of Stockton, and I left when I was a student, and then I came back like 6 months later or something. Like I just left Stockton altogether and came back like 6 months later to finish. Don't do that. It's better to just be punctual. And I wish I had me to tell me what to do back then. But yeah, just submit all the paperwork early, and then if you don't get it on time, that's fine. At that point, we'll just say, all right, you're going to graduate in the summer or something. But just get all the paperwork in. Yeah, March 23rd. Is that when it is? That's the deadline.
March 26th. It's like a Friday.
26th? Okay.
Yeah. Well, I'm trying to get it done early, but yeah, I wanted to know your experience because, like, I feel like if I defend that day and then send in the completion form, I feel like there's just gonna be trouble there, you know, and then the graduate school is gonna be like, well, technically you're late, and you know what I mean? Like,
there's a timestamp on everything because we're doing it digitally, and we've done a couple of thesis defenses, Mark and I have, and on Zoom, and there's a timestamp of everything. You send the email with my signature and Mark's signature, and it says the minute that it was sent, and so they have to honor it. So as long as we email things before the deadline, sometimes when you submit actual paperwork, and you sign it and you write a date on stuff like, oh, did you predate this? And we didn't see this form, and it can get a little bit messy. In quarantine, everything has a timestamp on it, a very objective timestamp. So as long as it's in like the deadline, as long as you beat the deadline by 1 second, that's fine.
sounds good. And then I've been meeting with Molly, and she told me, like, obviously there's no like page minimum or maximum because it's all based on the information for your thesis, but like the methods section's really small. So like,
How small?
I don't know.
I mean, are we talking like a page?
No, it's probably like 4 pages. Like
Okay.
I was able to stretch it out, but like she's like, oh yeah, each chapter's like on a smaller range, 15 to 20. And I'm looking at my methods and I'm like, I don't know what you want me to add. So like,
There are some theses that are 100 pages. There are some that are like 39 overall for like the whole thing. You can put in diagrams, make some diagrams, right? Inclusion, exclusion diagrams. Have one of those things where it's like total number of people, exclusion criteria, we eliminated people who are pregnant or whatever, and then have some little thing, and then how many people remain, and then we only enrolled people who this or that or whatever, and you can make little enrollment diagrams. You can make tables. You can, I mean, there's a lot of visual figures and tables that you can include, and each one takes up like a whole page. So it's like 20 pages of writing and 80 pages of diagrams. That's fine too. What I want people to do with the thesis, though, obviously, is publish. And so if you structure your, don't spend too much time making it thesisly, spend more time making it manuscriptly.
okay. Oh yeah, because like I'm putting in information, but like, I don't know. I've heard if you put too little information or your thesis is shorter, it like looks bad, or that's not recommended.
Yeah, but who does it look bad to? To Mark and me? I don't care.
Oh,
Okay. Again, the graduate school, Molly, is it Rencher? Is that her last name?
Mhm.
She's lovely and she's very helpful. in the past, I've asked if she could be on thesis committee, and she's like, no, it's biased because I'm in the graduate school. Like, as I would be accepting that, but okay, we'll just use you for help. But yeah, so the graduate school just needs to see that some minimums are met on things, but it's not. Don't stress out if there's one particular section that's a little bit short. If you know a way of bolstering it with more information, that's wonderful. But if it's just like, oh, I'm just squeezing in a bunch of bullshit into here, and it's just making it. I've added 3 paragraphs that worsen the product. Like, oh, okay, you don't need to do that. It's okay to be a little bit short there. But if there's material that's worth including, include that.
Okay. Sounds good.
So then should our theses all be on pre-collected data, or
whatever you want? It's hard. Okay, here's the problem is collecting your own data. It's just time consuming, and depending on, if you have access to a sports team, you just get everybody in there to do testing on whatever. That's one thing. But if you're trying to collect data for some specific question, if it's a questionnaire, you need tons of people for a questionnaire. If it's active data collection where you're measuring people on something, it's hard to get people to show up, and so you can do whatever you want. Half of our theses have been on data that I just have lying around. Half of the theses have been on data other people collected. Now, one of them was a mistake where I had somebody, I just didn't think he was going to collect the data. And so I had him use rib fracture data, and it took him forever because he just wasn't interested. He just didn't care at all about thoracic trauma. But I didn't think he was going to be able to collect any data, but I should have just seen if he could go give it a shot. Let's see if you can collect data. I should have had him do that first, because I don't think he would have gotten more than a couple of people, and it would have been really there was one person who spent a year collecting data, and she ended up with one subject. Like, that doesn't work. So I went to the hospital and got 610 patients or something like that within a month, and it was the same. It was fall risk is what she wanted. And so pre-collected data is so easy to have 600 subjects over in, just to have it, here's 600 subjects, as opposed to 10 hours a week for a year, and you wind up with one subject. Sometimes that can get harder than people think, collecting data. We had one person, his name was Albert Santa Cruz, that we permitted to publish his one subject study as a case study. Super short thesis, and we just sort of felt bad that, like, you've been at it for like a year trying to collect data, and you have exactly one subject. But why don't you do a case study? And it's the only time we allowed that to happen. It was fine. His thesis was fine, but it was just it's weak if it's only one subject, and it's hard to collect a bunch. It's hard to collect enough data. You look. That's a face of you're discouraged. Give me your aspirations. What do you want out of your thesis?
Well, like for Peter's class last semester, we worked on like the whole proposal process of it and whatnot. And for me, my aspiration was, like, I had like a whole idea, and I was thinking, okay, when the class is over, I could probably use some of that, but I would have to collect data, and that would be dependent on COVID and all. So
I think we're going to be in the fall available to collect data again. So if it's like a Proteus thing, that's easy to publish because Proteus.
No, this is like with school children.
Oh, okay. So we published one on that. Nathan Ray, this previous ACSM, I had him in 279 like 2 years ago or something, and that project he saw through to the end, defended it as his thesis, and it was on children, and it was swimmers, and he's like a swimming coach for kids. And he was looking at, he gave all the kids had a questionnaire they filled out, and it was about motivation and internal, intrinsic versus extrinsic motivation. And then he looked at improvement and performance and stuff of these different kids, and looked at age group differences, how motivation corresponds to performance. And it's a little bit harder to get through IRB if you're using kids, but it can be done. We did it, right? It was that one went into print in MSSE, I don't know, 6 months ago or whatever that was. So you can totally do that. It's just IRB is a little bit.
Yeah. I mean, yeah. I don't know. I mean, if it's a horrible idea, I mean, I have like at the end of Peter's class, we submitted like our proposal, like so with the intro, the review, and the methods. I mean, I have all that done. I don't know, should I send it to you and you tell me if I should do it or not?
Yeah, send it to me.
Yeah, you could be, if you think it's horrible, you can tell me. I won't cry. But
it's not going to be horrible. It's just whether it's well, maybe it's horrible, but I doubt it. But it's whether it's feasible. I think is
exactly. Yeah.
And so I'll give you some honest feedback on the feasibility of it.
Yeah, and then if not, then I guess I'll just come up with something.
We can talk through a topic, and then if you decide like I don't want to do thesis, just do comps at that point. But to get some publications and have the thesis, it's a good pursuit. The thesis is.
Yeah, and then I was also, I don't know if it's true or not, I was also under the impression that like to get into like a doctoral school, like you need a thesis over a comp.
You don't. What's the most helpful thing? I mean, far more than GPA, far more than classes and whatever, is publications. And you had a couple submitted this year. I don't remember how many, but next year let's get a bunch for you. And the thesis is really the avenue for publication. So the reason a thesis may be advantageous is if people publish it, then they have a publication. People who do comps usually aren't publishing anything. If they were publishing, they would have published their thesis. And so usually comp people didn't publish, thesis people may have published. That's the only difference, is whether you publish. PhD people, that's the only thing they care about is publication. Honestly, like GPA doesn't even matter.
Yeah.
GPA matters for clinical fields. They look at that. For going into a PhD is publications. Do you have that? Then you're in. Do you not have that? Why don't you go get some and then reapply? And so we can do that for you regardless of whether you do thesis. We'll get you some more publications. But pursuing a thesis is a good way of making sure you're still making progress on publications.
Yeah. Okay. Yeah. I'll send it to you, and then depending on that, we'll come up with another idea, and then if it doesn't work, come up with another idea. If it still doesn't work, then I'll do comp.
I switched dissertation topics after 3.5 years. So.
Oh geez.
Yeah, it's okay to switch thesis topics.
Yeah. It's not big. There's only a semester, anyways. But
yeah. Any other questions, comments, concerns?
I have a couple questions, but I could give the floor to other people if they have more questions. So.
I just had a clarification question that I wrote in the chat bar.
Let me open up the chat bar.
Yeah, it was just. Are you saying that we only have one question per teacher, or is every
one per class? Yeah. So every graduate class in HESP.
Okay. Yeah.
You'll have one question for.
Okay, so that includes Van Ness too.
Yeah.
Okay, because I was just under the impression that we were going to have 3 or 4. And so when you said that, I was just a little bit confused if it was just your class that was one question.
Everyone is going to be one question. So per class. So, have you taken 2 classes with Van Ness?
Yeah.
Yeah. So you'll have 2 questions from Van Ness, one for each class.
Okay, perfect. Thank you.
Yeah.
And then should I? I'm sending it right now. Should I send it as like a like just share the doc with you, or should I like email the?
Oh, can you just email my Pacific email address? I can't open like shared files.
Oh, okay.
Like it's my .edu Pacific one is not particularly friendly to sharing.
Just download it and then email it to you.
Yeah.
Okay.
I'm just gonna keep asking you questions. I feel like other people should ask because I'm probably gonna talk your ear off for a little bit. You guys okay with that or no?
I mean, because it's you, I'm totally fine with that, Lexi.
JP, actually you should go because I feel like you haven't asked your question yet.
Yeah, JP, what do you got?
I have like 3 questions about 3 different, well, they kind of relate. One's about the manuscript from the ACSM project, just because like I've told you, my dad keeps asking me, when is that being published? I just pulled up a document from like 2019 of basically a SketchUp of what I think the manuscript would look like. If that's cool, I'd share. Like I can share it with you and like see if it fits with within the specs of a manuscript. Or it's basically just like the poster in written form, with like all the charts and stuff. So I'll share that to you. The second thing is I'm still trying to figure out a thesis question in regards to like Tommy John. So maybe we can talk about that later in terms of like narrowing down like a specific question to ask based on the research I've already done.
Okay.
And then the third is the database. I'm in like the 300s for the monetary inputs. So,
good.
Yeah, that'll be a lot of fun to look at after I've completed all those numbers. So
yeah, definitely. I haven't had a chance to. I'm just looking at your Tommy John stuff right now. So I haven't had a chance to start on the stats yet.
Of course.
I'm going to.
Yeah. Oh yeah, right. Because that has to be updated in terms just based off of re-expanding the database from 2 semesters ago now, I think.
Yeah. Oh, there's I just got your email.
Yeah.
I'm just going to attach a couple of things just to make sure, you have these. The latest version of the poster. There may be a couple of differences in the poster from when it was presented. I think I may have changed a couple of things.
This was written after the conference itself, so unless if the posters were changed after.
I think I did change the poster a little bit after the conference because I was getting ready. No, but it's fine. I mean, you just look at what's if there's something that's updated. I'm just trying to find where I found the posters, where I kept it. There it is. Yeah, so it may or may not have changed, but I'm just attaching the poster and a couple of other things just for you to take a look at and make sure you have all that information. And then I will rerun the analyses with the updated.
Attached to the document, or just email it to me?
I'm just emailing it to you. It's still loading. It hasn't.
Okay. How about them Yankees, Lexi?
I'm so happy we acquired another pitcher. I mean, like
I just kept seeing like that's all the trading news recently has been about the Yankees and the Padres, but the Yankees are more. I'll pay attention more to the Yankees and the Padres any day. So.
Yeah, I mean, because of course where I'm from, there's a lot of Dodger fans, right? So I looked at them and I was like,
bro,
you guys are in trouble this year. Like the Padres are stacked with Blake Snell too. Like,
yeah, the Padres really went all in. They said, "Screw it, we'll just get every big name pitcher that's on the market right now. We'll just collect and trade for them." And it's surprising that I don't think the Padres have relinquished any of their top 10. So, in terms of prospects, which is a really smart move on their half. So, and they have the payroll ceiling for it, which is great. So it's like it's a win-win kind of for the Padres.
Oh yeah, they're really smart about it this year.
Yeah, but I was surprised when the Yankees re-signed DJ, although it's a great move on their part because he has a lot of versatility around the infield. But it's one of those things where I'm surprised that DJ didn't test the free agent market, but he did exceptionally well in New York, so it's good to see him return.
Yeah, I mean, I think there's a lot of factors into that, but Yankees are gonna they're already at the point where they're competitive. They're making it to the playoffs.
Yeah.
They're just or close to the playoffs, but they're just not there yet. But they will be at one point. They will be at that competitive level. So sure, DJ could have signed elsewhere, but he's already in a good position.
Yeah, I
on
think
a good team,
Yeah, it's gonna. I think this year. I think now that they're trying to make it like a full season again, it's gonna be a lot more interesting to see how everything plays out.
Yeah, instead of them arguing over their millions. Oh my god.
I mean, I think the Dodgers actually surpassed in payroll ceiling by like a couple $1,000,000.
Yeah, well, they're stupid. They're signing players that are for millions of dollars, and it's for what? You could get someone just as good that will be more than happy to play for you. So
yeah, I think just I think with that, just the Dodgers are trying to be like the Yankees of the West, and they got really lucky with 2020, but of course they won in 2020 because it's it's the Dodgers of the Dodgers of years. Did you just send me the references, Jensen?
Yeah, I don't know if I did. I said that, and then there's three. I sent you 2 emails. So
Okay.
one of them has 3 things in it, and then the follow-up email just had a little thing of references because the references had 2 additional tables. Just
Okay,
making sure there were tables.
all right. I will add those. I think I put those in there already.
Those additional tables and stuff. Yeah, so just look through that stuff and just make sure there's nothing missing in your draft and the versions I sent you. And I can run new updated stats for them.
That would be great. Yeah. And then we can hash out everything else from the other 2 questions later because I yield my time to Lexi.
I do think your thesis should include the database you just finished making, the other baseball one too.
Oh, the
Tommy John and because just pitchers, baseball pitchers and determinants of performance.
Yeah.
Now on the injured side, on the optimal side.
I keep calling that database that I'm working on the beauty of a beast because it's a large database. But
beauty of a beast. Really good database. But yeah, I'll start working on it at some point. It's gonna be on a weekend or something.
No worries. Yeah. All right, y'all have a great rest of your day then. I'm gonna head out.
All right, I'll see you.
Get back to researching.
Nick, Lexi, you guys got any questions?
Yeah, so now that you're telling me the content length doesn't matter, I've been I have 3 chapters written so far. So I was just buffing those up. Now should I shift my focus?
Buff them in an effective way, but just don't make sure it's just I mean, if it's just unnecessary length, where it's okay, 1 word will suffice and I'll put in 6. So don't do that part of it. But if there's what would be good here is a table, or what would be good here is an explanation of that, where it's something that sort of buffing, where it's not just pointless. If there's that stuff, put it in. Otherwise, I would just move forward.
Okay, because I was trying to, because that's what Molly said too, is you want to add info, but not pointless stuff or stuff that doesn't support your question.
Mm-hmm.
So I've been trying to focus on having people not in this background understand the importance of it, especially in chapter 2. But yeah, now that you said that, some people publish with 34 pages, that's what made me think okay, well, at this point, should I just move forward?
Just move forward, and then because the one thing when you get to the end, you might have ideas of something to do when you go back. So if you're I finished chapter 2, I finished chapter 3, okay, but now when you get to chapter 5, you're like, oh, you know what I need to do here. And so if you just sort of work your way to the end, then you can start revising at that point. It's a huge mistake that people make when they're like writing a novel or something, is they spend all this time in chapter 3 in like a 50 chapter book. And then they get to the end, they're like, oh, I can't even use chapter 3 anymore. It's not consistent with the ending. And they spent like a month on chapter 3. So get through the end, and then you can make those edits at that point more easily if you realize there's a weakness or a hole or some expanse that could be populated with more information.
Okay. And then, sorry, I just like, I wanted to ask you, but I was like, I'm not sure. So like, it's on the optimal load database. What should I focus on? Like, in your opinion, like, should I, because Jacob wrote about power and then Zunin took men versus women.
Yeah. I mean, that's fine. You can do those things as your thing, because you were on both of those, right?
Yeah.
Fine. Yeah. Just because somebody else is published, that doesn't mean it doesn't belong to you too. It's never been a thesis before.
That's true. All right. And then, sorry, last one, Nick, and then okay, maybe 2 more. Nick, do you want to go? I'm sorry.
I don't have anything. I'm just trying to. I don't have anything. You're good.
Okay. And then, so for the random author, I was thinking like either my coach or Janet Lucas, but I feel like my coach doesn't like me. So I was like, would Janet Lucas be better?
Who's Janet Lucas?
She's like the athletic director.
Oh, good. Yeah. If she's willing to be on it, that'd be great. If you have a relationship with her or you've met her before and you feel comfortable reaching out or something like that. I've never met her, but obviously I didn't know who she was. Have you spoken with her before?
Yeah, I mean, I think I would have to like reintroduce myself to spark her memory, but like I actually went up to her and I talked to her because I read about her past career and what she did at UC Riverside. So I think she has a lot of respect for me for going up to her and acknowledging her existence, unlike a lot of other athletes. But
okay, ask her. Have that be your first option, and then if she's like, oh, I'm too busy, none of my sports are even meeting and I have nothing to do, but I'm too busy, whatever. she may be, this may be like the busiest time of her life as she, navigates, COVID closures and stuff. But ask her if she's unwilling, then go with your coach. If your coach doesn't want to do it, then we just use like, Peg or something, Sharon or Peter or something.
Sounds good. And then this is just life advice I need from you. So like I'm trying to like retake classes that I didn't do too well in an undergrad.
Okay, I'm gonna stop the recording. I think it's still recording.